Bismillahirrahmanirrahim and good morning. Today we look about the function. Function or we mapping the relationship to each element of a set. Okay, exactly one element to another element of a related set. And function find their application in various fields. Okay, for example here we study sequences of a set. Okay, in mathematics, especially to measure a set function is a function whose domain is a family of a subset of a given set and takes its value in an extended uh, real real number. Okay, and then most probably a function is to mapping the relationship. Okay, the relationship of a set. Okay, and then for the recap, last slide, we have seen ordered and unordered collection of object. Basically, a set is a element or member, an object in a set. And then we can have element in a notation of bracket. And then cardinality is the number of distinct element in the set that we can represent by this one is the number of element. And then we have also seen the power of set. And then this one is the set of all subset of a set. Okay. Basically, we can represent this one as a power of set as 2a. And then we have also seen the Cartesian product of two set. While this one is set A and set B. A is a member or A is a element of set A and also B is a member of set B. Okay, cardinality. Okay, and then we also seen the union. A union B can be represented in the logic as N or okay, and then intersection is N. Okay, and then we have differences. Okay, differences set A minus set B is equivalent to X, whereby the X is a member of A and X is not a member of set B. And then we have also seen the complement. Complement. Okay, for example, we have A, set A, and then the rest is the complement. Okay, complement of set A. Okay, and then identity is similar to those from logic. Logic, we have seen logic in chapter 4. Okay, we have union and intersection. Okay, this one is De Morgan law. Okay, and then definition. Let A and B be the set. Lah. We have two set here. And then a function f from A to B is a sign of exactly one element. Lah. Okay. And then of B to each element of A. Lah. We write if A equal to B, function A equal to B, if B is the unique element of B assigned by the function f to the element A. If f is a function from A to B, we write f a function from A to B. Okay, so far do you have any question? Is it okay? Okay. Jadi kalau ni tengok kat YouTube saya. Okay, please be reminded, a set is a collection of objects that can be called as the element or member of the set. Okay, and then we introduce the function. Function. Let's say we have function x from x to y. We can assign each element of x is a member of set x, is a unique element of fx, is a member of y lah. Okay, let's say we have another function f, x to y. Function f from x to y. Okay, between set x and set y assigned to each of element. Okay, we can see that x is a member of x. Okay, and then fx. Okay, and then we can say fx is also a member of y. Function also called a mapping, a maps or transformation. Other name of function. Okay, function also you can see as a mapping or transformation. Okay, and then the set x on which f is defined is called the domain of f, and the set of y in which it takes its value is called the codomain. Later we see what is domain and codomain. Okay. Okay. Next. Okay. This one is function. We have a domain and codomain. We can see A set A is the domain of function f, and B is codomain of f. If a function A equal to B, we can say B is an image of A, or sometimes we can call it as a reimage. Okay. Uh, okay, and then the range of F is set of all images of element of A. Okay, we have the range. The range of set F is the set of all images. Okay, for example, we have F function R equal to R, and then Fx equal to x power of 2. And then x is the element of r. R is a real number. Okay, so far do you have any question? Okay, thank you. Okay, in mathematics, the codomain of or a set of destination of a function is a set into which all of the output of the function is constrained to fall. Okay, okay, and then it is the set of y in the notation of fx implies set y. The term of range is sometimes ambiguously used to refer either the codomain or image of a function. You can also say codomain, or you otherwise you can also say codomain. Okay, and then in a simple terms, domain related to the input of the function, and codomain and the range are associated with the output of a function. Okay, please bear in mind domain is related of the input. Okay. Okay, basically we talk about the domain and codomain. Domain basically we refer to the input, and then codomain is we refer as the output. Output, or sometimes we call it as a range. Okay. Okay, and then a codomain of a function is any set that containing the range of the function. It does not have to equal the range. For example, a function y equal to x power of 2 has a codomain, the set of real numbers, which is containing the range of y greater than or equal to 0, but it is not equal to the range. For example, we have the example of codomain. Example, here we have a function, function y equal to x power of 2 lah. Okay, and then has a codomain of set of real numbers. Okay, we have real numbers r, which can denoted as r. Set is containing the range is y must be greater or equal to 0, but is it is not equal to the range. This one is not equal to the range. Okay, it's not the same. Okay, and then what is differences between domain and codomain? Speaking as simply as possible, we can say that we can define also what can come out is a domain, and what can go into the function is codomain. Okay, what can come out is domain. Okay, this one. What? Okay, okay, is codomain, and what can go into a function is codomain. Ama boleh ke Ama? Okay. Okay, then okay, for example, we have function 2 is equal to 4 because this one is f. Okay, and then f map 2 to 4, then and then the image of 2 is under the function of f lah. Since f 2 is equal to 4, it implies that x equal to 2 or x equal to negative 2. And then the pre-images of 4 are 2 and also negative 2 lah. And then the set of pre-images of 4 is we have both 2 and negative 2 lah. Okay, this one is another example of domain and codomain. Okay, another example, we have suppose that we have each student in the class is assigned a letter grade from set A, B, C, D, and F. And then let G be the function that assigned to grade to a student. Okay, and then we have seen uh, for the domain is what can go out. What can go out is called domain, and what can okay, we can see this one. What can go into function is a codomain. Okay, what can be go into function is a codomain. And then, for example, we have a grade, grade A, B, C, D until F. And then we have how many students here? Five. We have several Stokes, D's, Dosdier, and Holland. And then we map from the domain to codomain. And then the range that we have seen here only from A to D lah. And then F is not included. Okay, because domain can be mapped into the codomain several times lah. Okay, several times. Later we see the another uh, parts. We have a bijection, a bijective, and then we have injective, and so on. It's based on the domain and codomain. Okay, another is example. We have integers function, and then we selected the domain integers z for the domain, and codomain is also integers. Okay, and then that assign the square of an integer to these integers. How can you write this function fx equal to x power of 2? Okay, and then other than that, we can also have the natural numbers. We can also have the positive integers and rational numbers. Rational numbers. Okay, and then what is the domain of the f? Basically, we note that this one is the integers. What is the codomain? Also integers. What is the range of the f? Is non-negative integers. Because integers we can have from 0. Okay, and then we have 1. 1 power of 2 is 1. 2 power of 2 is 4. Okay, we can see here. And then 4 power of 2 is equal to 16, 5 power of 2 is equal to 25, 6 power of 2 is 36, and so on until infinity. And then if you want to map, you map from the x to function, because from the codomain to domain. Okay. Okay, and then we have fx equal to x, and then we have negative 2, negative 1, 0. We mapping the range. This one from integers to integers, fx to x. Okay, we can have -1 to 4, okay, -1 to 1, 1 to 1, 2 to 4, 3 to 9, okay. And then 2, 3 is absent, okay, 2, 3 was absent, and 5 until 8 also absent because we mapping for the certain range because x is power of 2, okay. And then okay, this one we look into the smaller details of the function that we name it as the one-to-one function. Okay, one-to-one function is no value in the range is used by more than one value in the domain. Okay, for example, if fx equal to fy, function y, then x equal to y for all x and y in the domain of f. Okay, we have domain x and codomain of y. Okay, and then we have ABC, and then we have codomain of y 1, 2, 3, 4, and then the codomain numbers must be the same of domain because domain we have three, input we have three, the output must be three, and then this one is at most one element. At most one element, we map at most one element. And then in other words, we can say also in a logic for all x, for all y, whereby the function fx is equal to function fy, implies the x equal to y lah. And then or using the contrapositive, we negate the statement. For all x, for all y, x is not equal to y, whereby the function fx is not same with the output of function fy lah. Okay, is it okay? Iza okay ke Iza? Okay, in mathematics, an injective function is a function of f that map a distinct element to the distinct element. Okay, distinct element means that you have distinct. You can count the domain and codomain. That is f equal to f implies x1 equal to x2 lah. In other words, every element of function of codomain is the image of at most one element of its domain. Okay, at most one element. Okay, and then this one is injective function, one-to-one function. Okay, and then the other example, okay, wait, I plug in the, plug in the laptop. Okay, injective one to one if x. Okay, we have if x. Okay, we have here. Okay, we have x1. Okay, okay, and then this one is a function. Okay, injective one to one. Okay, we take a function from f or function from x to y, so we can have our domain going to codomain. And I'm going to illustrate with this diagram for each one that what that say if x1 is not equal to x2. So far for the instance of x1 and x2 here are different. Okay, then we always get x1 going to different x1 going to different y value than x. Okay, we map this one we map. Okay, we rest 5 minutes.